Guys, I'm excited. Really excited. In the previous days, I got a comment from Ajay Ghosh. He asked me a question about how to get the firmware back, how to get the hex file back from the Arduino. Wow, such a nice question. I know there is many of you have the same doubt, so I decided to make a video about it in detail. So let's jump into the video. Here the Arduino is running an LED blink program on its fourth digital pin. For the demo, we are going to copy the firmware of this program from this board to our desktop PC. Means copy the hex file of this board to our desktop. For doing that, we need a programmer. In my case, I don't have a programmer, so I decided to make one of them using the Arduino Uno. It's really simple. For doing that, just upload the Arduino ISP sketch to the Arduino board. Just browse the file, examples. On that examples, Arduino ISP. Then go to tools and select the Arduino connected port and select the board type and make sure the programmer is USB ISP. Now the programmer is USB ISP port COM4 connected board Arduino Uno. Okay, everything is fine. Just click that upload button. After uploading this sketch to the Arduino board, it will act like a programmer. So we can use that as a programmer. I will show you how. Now our programmer is ready to pull back the hex from the target Arduino board. So the next step is to wire this programmer to the target Arduino. This is the target and this is the programmer. This is the target, this is the programmer. Now we are going to connect the wires to the target Arduino to the programmer Arduino. Target to the programmer. We need 6 wires to complete the connection. It's really easy, but by looking this video, you feel it's like horrible. So I don't want to confuse anyone. So I decided to draw a diagram for you. You can look that or you can download that from my video description. Okay, now the wiring is done, and next step is to connect the programming Arduino to the PC using a USB cable. Now you can see the program is running on the target Arduino. Now we are going to copy that program to our desktop PC. For that we need some tools. Here we are using Aviar Dudes. It's a programming software for the Aviar chips. On that, select the programmer type. In our case, it's Arduino, and programmer port. We don't know what the port is. Just go to the device manager. On the device manager, there is an option ports COM-LPT. There you go. Arduino is connected in COM4. So select COM4. Then you can see 3 options: write, read, verify. Write, read, verify. Because this software is not only to read from the chip, but also you can write to the chip. It's a complete programming software. So after all that, just click the detect button if your connection and everything is right. Then you can see the chip detected dialog and chip signature and name in the black window. Okay, let's move on to the next step. Just read these fuse and lock bits. Then some values are pop up on the text box. There, just copy everything to a notepad file. This is the configuration settings of the chip. It defines the processor clock selection, brownout, voltage level, program memory lock, etc. So we don't want to change these settings. If you are going to change these values, it's not gonna work like the way you want. Keep that in mind. Okay, we copied every value from the fuse bit text box to a notepad file and save that file. That's it. Okay, let's move on to the next step. Here you can see the flash browse tab. It's used to browse the hex file to burn the chip or browse the path to save the hex file that we pull back from the chip. Okay, let's set the path to save the hex file. In my case, I'm going to save this on the desktop with the name Blink. You can use any name. It doesn't matter, but the important thing is it always ends with an extension .hex. Keep that in mind. Okay, in the bottom of the browse tab, you can see write, read, verify options. That is the purpose of the location. So we want to read the file from the chip. So take the read and select the format. We need the Intel hex format. That's the format of the hex file. And do the same for the EEPROM section, because some of the program use the EEPROM of the chip and there is always data. So browse the location to save the EEPROM file and do name it whatever you like, but always keep the extension .eep. Okay, now we are going to pull the hex file from the chip. Just click the go button. It's reading the chip memory. It's pretty slow, but it's not a problem. We need the program from the chip. By this way, you can copy any program from the Arduino boards and any AVR microcontrollers. But there is one condition. It is only possible when the chip is not copy protected, means it's not locked. In the case of Arduinos, there is no copy protection. Anybody can pull back the hex file from Arduino like this. So this is a technique you asked for. And here's our boy we pulled back from the chip. Okay, it's not over yet. We want to pull back the EEPROM data too. So just click the go button, boom. Now it starts reading the EEPROM file. It's reading. Oh my god, it failed. Because we forgot to keep the format Intel hex. Try it again. It's reading. Okay. That's our boy right there. We all know in the case of an LED plugin program that's not using any EEPROM memory, there is no EEPROM data. But in the future, if you are copying a large program that using EEPROM data to work together, in that case, you want to copy the EEPROM data too. So that's why I am showing you the technique to read the EEPROM data to your system. We can always open hex file and EEPROM file in notepads and check if it is empty or not. But please don't make any changes inside the files. That will corrupt our program and EEPROM memory. Now we are going to the last final step. Now we got the hex file from the target Arduino and EEPROM file from the target Arduino, and we always know the configuration settings of that Arduino board. Now I don't have a spare Arduino board anymore, so I decided to erase the program of this Arduino board by just uploading a blank sketch to it. Open the Arduino IDE and go to Tools and select the board port. In my case, it's COM3. Then board type Arduino Uno, programmer USB-SP. Everything is fine. Just click upload. We don't want to save this anywhere. It's just a blank program. Just upload it. Now it's just compiling the blank sketch. Okay, it start compiling. Started uploading. After uploading this, look. See, Arduino board is stopped blinking the LED because there is no program. It's erased completely. Now we are going to burn the hex file that we pulled back from the target Arduino. These are those two files that we pulled back from the Arduino, and these are the copied program from the Arduino. Now we are going to burn this to the Arduino. For that we have two techniques. One is the simplest one and one is the advanced one. First of all, we are going to do the simplest one. The simple way to burn the hex file to Arduino board is by Explorer application. Click on the hex file browse tab and browse the hex file that we copied from the Arduino earlier and select the board. In our case, it's Arduino Uno at Mega 380p. And there is something more to tell, because if a program is compiled for a particular processor at a particular speed, it's not going to work on another processor with a different speed or the same processor with a different speed. So please keep that in mind. Now select the COM port and click upload. Then it's uploading now. It's uploaded done. Now see, it's running. It's running the copied firmware from an Arduino. Now the program is running fine. Now the copied hex file is running fine now. Now I will show you the advanced step to burn the hex file, EEPROM file with the configuration bits. So let's jump into that. By the same way, uploading a simple empty sketch, I erased the Arduino and it's now completely empty. And connect the programming Arduino to the target Arduino like what I did here before. Now the target Arduino LED is not blinking because it's empty, it does not have any program on it. Now let's open the AviaDude. You can always erase the chip using AviaDude, but I erased the Arduino by a blank sketch because we don't want to make any confusions here. And check on the both button tabs to write. Now we are going to write to the chip. Okay, let's browse the hex file here. Open, then browse the EEPROM file. Open. Okay, we browse both files. And programmer Arduino comport 4 detect the chip. Yes, the programmer communicates successfully with the target. Everything is fine. Now let's remove the fuse bit values that are default on this application. That's the previous values. Okay, let's open the config bit file that we saved earlier and set every fuse bit values. LFuse value to LFuse, HFuse value to HFuse, EFuse value to EFuse, and LB lock bit value to lock bit. Please don't make any changes in this section because it will hurt the MCU. That's I told you earlier about the fuse bits and lock bits. Okay, we copied every values right. Then check the set fuse and check the lock bit. Then check the erase, flash, and EEPROM option. It's a good practice and it will make the programmer erase the chip first, and after that upload the new hex. That's it. Let's click the program button, then it will do every process as by process by process. What I mean by that is it will do everything step by step. You can see, you can observe every steps what the programming software is doing to the chip. You can observe that in the black observation window. Now it's erased the chip and it's writing to the flash memory, and you can see the LEDs are flashing on the programmer Arduino because it's indicating the reading and writing process from the AviaDude application. Now it's writing to the flash memory. It's almost done, almost done. Yes, it's finished. And it starts the reading process to verify if it is done right. Okay, it's reading. It's almost done. Okay, it's done. It's done. Then it's verified. Now it started writing EEP file to the EEPROM. That's why I told you it's a step-by-step procedure. It will do every step automatic. Writing EEPROM is pretty slow than the flash memory. It's writing, it's take a bit of time. I'm not fast forwarding anything here because that will make better understanding. Okay, it's writing. Okay, it's almost done. 70%, 80%, 85%, 90%, 95%. It's still writing to the EEPROM. And it's almost finished. Yes, it's finished. It's reading the EEPROM memory to verify if it's done correct. After that, it set the fuse bit and lock bit configurations. It's already verified. Now the copied program from an Arduino is running on another Arduino. That's amazing, right? I hope you learned something from this video. See you in the next video, guys. Bye.